Today we're going to discuss sequences, and sequences are numbers that are in a certain order, and a sequence is a function that with the domain, so those are the values we put in, of consecutive, positive integers. Now, an example of a function would be, or a sequence would be a list of numbers like 5, 10, 15, 20. Each individual member of this sequence is a term. So each member is a term. And the notation we use for that is we'll use the letter T with an N or a 1. The N shows any number, but this would be the first term. So whichever number you put next to your T, that tells you what position. So T sub N, that would be the nth term. Now, an arithmetic sequence describes a sequence where the members of your sequence, each term, well, let's use the word term, the terms have a common difference. And we use D for difference. And the way that you find the common difference is you subtract two consecutive terms, and always go with a term of higher position. And the way you get an arithmetic sequence is add D for the next term. Now we have two examples. Example 1, for the arithmetic sequence below, we have 9, 7, 5, and 3. We want to find the common difference in the next four terms. So we've got T1 through T4, and we're going to find the difference now. Now this 9 is T1, 7 is T2. So we're going to subtract those two terms. So 7 minus 9. And as you can see, our sequence is descending. It's going down. So what we want to do for our next four terms is that you're going to add -2. And we want to think of it as adding a negative as opposed to subtracting. So if we have 3 and add -2, our next term is 1. Go down 2 more, -1. -3, -5. That gives us our next four terms. Now the one below, example 2, we have 3 to 4.5, 4.5 to 6. So every time we're adding 1.5. So we're going to start by adding 1.5 to 7.5. So our next four terms will be 9, 10.5, 12, and 13.5. And this is a repeated screen, so we'll skip that. Geometric sequence is a different type of sequence, and the geometric sequence, the terms have a common ratio. Ratio is a word that we use involving fractions. And we have R is equal to T2 minus T1. Here, you multiply for the next term. So an example would be is to find the second term, we would multiply the first term times r. And that's what we're going to do in example 3. For the geometric sequence below, we want to find the common ratio in the next 4 terms. And the ratio, 20 divided by 40, that's 1/2. And it's the same thing if you divide 10 by 20, you're going to get a 1/2 with any geometric sequence. So we're going to multiply by the last term we have. So if we take 10 and multiply it by 1/2, that gives you a 5. 5 times 1/2 is 5/2. 5/2 times 1/2 is 5/4. And then we'll have a 5/8. And that would be 4 more terms in our geometric sequence. Example 4. For the geometric sequence below, we want to find the common ratio. And I'm going to have you pause this video and try this one yourself, and then come back and check the answer. Okay, we would get a ratio of 2, as we're multiplying by 2 to get from 3 to 6, and then from 6 to 12. And then we begin with number 24 and continue to multiply by 2 every time. So every time times 2, times 2, and that was the 2 squared right there, times 2, and then times 2. So many times our sequences are determined by a particular formula, and if you look at example 5, I've given you a formula for the nth term. So it's telling us actually what is going to make up our terms. So we're going to have to find T1, 2, 3, and 4. Now with T1, that n here, that 1, also goes in to the formula. So we'll have 1/2 times 1 minus 1. Don't subtract first, multiply first, and this gives us a negative 1/2. Let's try the second one. 1/2 times 2 minus 1, multiply first, PEMDAS, and that gives you a 0. Substitute in 3. So 3/2 minus 1 is positive 1/2. And then the last term, we have 1/2 times 4 minus 1, and that gives us a 1. Now, we want to see whether this sequence is arithmetic, geometric, or neither. So we're going to check common difference. That's the easiest one to check. You have to check more than one interval. So between T1 and T2, we're actually adding a 1/2. Let's check another. Just have to check 2 consecutive ones. We subtract 1 and a 1/2, we'll also get 1/2. So we have a common difference, so that means this one is arithmetic. Let's try the other one. So T1, this tells me to square the 1, and then subtract by 1, and that gives me 0. And T2, square it, subtract by 1, that's 3. T3, square it, subtract by 1, that's 8. Now before I go any further, what I see is this difference is 3, but the difference between 3 and 8 is 5. That's not arithmetic. Let's keep going. And then T4, 4 squared minus 1 equals 15. Now let's look at these. first of all, I can't divide T2 by T1 because that's undefined. And 8 divided by 3 is not the same as 15 divided by 8, so it's not geometric either. So this one is actually neither arithmetic or geometric. Okay, the last example. We're going to find the next two terms in the sequence 2, 6, 12, 20, and 30 by using the pattern in the difference between the terms. Because our difference is not common here, we are going to look at the difference between the terms. So what I like to do with these problems is to write out the numbers like so. And then I want to see the difference between these two. So I had to add 4 to 2 to get a 6. And this is 6. Subtract those two. Subtract those two. Okay, what I'm seeing here is that between each one of these, I'm adding 2 right here. So if I add 2 to 10, that gives me 12. And so I would add 30 and 12, and that would give me 42. Okay, I've got to do one more term, and it looks like this will be a 14. Add 14 to 42, and we get a 56. And those are our next two terms.